All right, now we get to the most realistic equation in this unit, where we're not, we're going to start accounting for things like viscosity. So for example, let's imagine we have, kind of a heart, and we have an artery that's flowing out of it. Okay, so the radius of the artery we'll call R, and the blood's going to be, using pressure to pump. The heart's going to be using pressure to pump blood through it. So P1 is going to be the pressure that the heart's putting on it, and then P2 is going to be the pressure, at the other end of the artery, as it's getting to whatever other arteries you have to move blood throughout your body. Okay, so we define Q as the volume flow rate. Well, that's what we already saw. So that if we look at kind of the cross-sectional area of this, times its velocity, how it's going through, this is Q. Okay, and we say that this is equal to pi times R to the fourth P1 minus P2 divided by 8 times eta times L, where we define L is the length of the tube. And so this is for just a tube in general, not necessarily even on the heart, but this is saying that we have some kind of tube, but now we're introducing viscosity. So eta is the viscosity of the fluid. Okay, and then again, P1 minus P2 we see is the difference in the pressure. So sometimes we refer to this as the pressure gradient. So it's the change in pressure. Again, we see that R is the radius of the tube, and that L is the length of the tube. Okay? So there really aren't a whole lot of problems that I can ask you on this, but except to look at some specific cases. So for example, let's say my arteries are clogged. Okay, so I have a lot of gunk on the side of these, and so what it's caused is my new radius R prime to be equal to 3/4 the original radius of the artery. Okay, so notice that if I say R prime to the fourth, this is going to be, so 3 squared is 9, and 9 squared is 81. 4 squared is 16, and 16 squared is 256. And this is about 1/3. Okay? So this is telling us, we're saying that this viscosity of the blood is basically going to be the same. The length of the tube is going to be the same. Pi is the same, 8's the same. So now if the radius to the fourth term has gone by 1/3, then that means that P1 minus P2, okay, has to go to 3 times P1 minus P2. In other words, we have to have 3 times the, 3 times the change in pressure from the heart. So it's like working, 3 times harder to keep up the same flow rate as we pump blood through the heart. So you can see that just because of this term to the fourth here, it means that a very small change in the radius, so just a little bit of clogging, can actually cause the heart to have to work much, much harder.